Hey there, math fans. Dr. Andy Lovelace. This is part 2 of my discussion of 15.2. Again, I'm making this in the summer of 2025 as a lecture replacement for my summer class. But I hope this is helping someone else. If it is, let me know in the comments or give me a like or something, and check out some of my other videos. So I thought I would, since the other video went a little long, I thought I would do an example. This is an example I typically do in lecture, which is to find this volume between these things. Okay, the surface itself is this surface, and we're finding the volume above a triangle. But if I just restrict it to this, it's this volume. Oh, so an interesting little sharp shape here that we get. Okay, so the challenge is to draw the region and then decide whether we want to do it in terms of X or Y. Now, I sometimes see on the test, people just start randomly putting numbers in. The moment you realize it's not a rectangular region, there will be variables in your bounds. So sometimes people want a longer review of this, so let's go. Since I'm doing it in this video format, we can do this. For those of you that this is more straightforward, do try it on your own first. After I do this example, I'll look at a couple of homework examples so you can skip ahead in the timestamps if that's more your speed. Okay, so I'm going to draw the picture twice. 0, 0, 1, 0, so here, and 1, 3. And then I'm going to draw it again. 0, 0, 1, 0, 1, 3. And I'll label these different sides. So here I have a line. Let's use the same colors. Here we have this. And we will be able to do this problem if we can appropriately label. We have two choices. We can do it in terms of X or in terms of Y. So let's just label a random X here, and let's label a random Y here. So if we can appropriately label, we will be able to set this up. Some students go, well, we don't know the equations. We do know quite a few of them. This side here is X equals 1. This is also X equals 1. The bottom here is Y equals 0. It's also Y equals 0 here. So the only thing we don't know is the orange, but it's a line. Sometimes I have students that want to review how do you find the equation of a line. So just very briefly here, I have 2 points, 0, 0, and 1, 3 on the line. I can compute the slope, 3 minus 0 over 1 minus 0. And the whole idea of the line is if you take any other point on the line, then the ratio will be the same. So y minus 0 over x minus 0 equals 3. That's where this whole thing about lines came from. But the equation is y equals 3x, because the intercept is 0. Y equals 3x. It is worth your while to take, if that's confusing to you, come ask. Because that needs to be sort of automatic, everything I've done up there. Okay, so now our job is either label in terms of X, and in terms of X you should see, and you can even do this right now, what is the biggest and smallest X can be. So sometimes I'll wave my hand across the screen and I'll say, okay, if I walk from left to right, hit the buzzer if I enter the region. Here's what I mean. Not in the region, not in the region, not in the region, not in the region, in the region, in the region, in the region, exit. And I have students tell the buzzer. That's how you figure out the biggest and smallest X can be, and it's 0 to 1. So if you're going to do it in terms of X, this is what you're doing. You're trying to find a pattern based off of this, and that pattern will involve variables in some way. If there are not variables, something is going wrong, because that means you're assuming it's a rectangular region. Separate from that, we can do the same game this way. When do I hit the region? At 0, in the region, in the region, in the region, in the region, exit. So y goes from 0 to 3. Let's get rid of those. So we can say the integral from 0 to 3 dy, and we're trying to find a pattern based off of that for x. And again, there will be variables there. This is just describing a region in the same way you would have in Math 125. Now what you need to do is, in terms of x, find how far this is. When would you turn on your mower? What is that y value? And when would you turn it off? What is that y? You can see where it's helpful that I immediately labeled x. That helps relieve a lot of problems I see students make. So we just need to know those distances in terms of x. So this is just 0, and it's going to be 0 no matter where you draw this. The bottom is 0. So some students like to say, okay, is it bottom and top? Yes, it's bottom and top. But you also just think about that's the smaller y value. Y equals 0. You can also think about labeling the point. I find different people have kind of different perspectives. You could label this point x, comma, 0, and that's true over the whole region. That's the lower point, or the smaller y. You can also just do a pattern, and I'll do that in just a second. The upper point, this length, is what and I've seen sometimes it's the mistake the confusion students have is they don't realize that if the equation for the line is y equals 3x and this is x, then that means this is 3x. I've noticed over the years that sometimes students don't know that. Like, they know how to find the equation of a line, but they have no idea what it means in terms of lengths. So if that's you, we've just hopefully remedied that. That's how you label your graph. And that's what goes here. And this would be x plus 3y squared. Again, if this is all basic for you, you can move forward, skip to the next timestamp. A comment here is what we just found was a pattern. If you ever want to test it, you can make a little table and say, well, what do I get when I plug in 0 for x? Well, the pattern I get is 0, y is between 0 and 3 times 0. Well, that's weird. What does that even mean, 0 to 0? Let's do one more before I explain. If x is 1, what do we get? The pattern is 0 to 3 times 1. Does that make sense in my picture? So in other words, if I stand here at x equals 1 and walk, does it make sense that I go all the way from 0 to 3? Yes. If I stand at 0, what's my up and down range? It's just 0 to 0. What if I stand at like a half? Well, then it's going to be 0 to 3 times a half, or 1.5. Does that make sense that this is 0 to 1.5? That's all we're doing, is finding the pattern for what the range is based off of x. You're just trying to touch every point in the region. Okay. Separately, so if you want, you can just think of it this way. Label a random x. I get lots and lots of questions on this, so I'm just trying to say it in as many different ways as I can. You can still ask me follow-up questions. So that point right there is going to be 3 times x, and this point right here is going to be y equals 0. That's the bottom, that's the top. I'm just trying to say it in lots of different ways. Okay, the other one, if we do it in terms of y, this is the left. Now I find that's hard for some students because they're not used to thinking in terms of left and right, but this is the smaller x. This over here is the larger x. How can you tell that? Larger on the x-axis is to the right. Smaller is to the left. So I need to know what that smaller x is. You cannot say 3x. That does not make sense. Because what I'm saying is I'm going to give you a y, and I want to know the range for x. So if I hand you y equals 2, it doesn't make sense to plug that 2 in for x. It makes sense to plug it in for y. So you need to rearrange that equation and get, oh, for this point, so I know when I'm standing at that point that y equals 3x, but can I write it in a more friendly form? Yeah, I can say x is y over 3. That's the smaller, that's what this is, y over 3. Y over 3. The bigger is always x equals 1. And again, you could test it out. When I plug in a 2, I'm going to go from 2/3 to to 1. Does that make sense? Is 2/3 smaller than 1? Yes. If I'm going to plug in a 0, which means down here I'm expecting it's going to be 0 to 1. Is that what my pattern gives me? It does. It gives me 0 to 1. All that was pattern finding. Okay. So that's the important thing. I spent quite a bit of time there. Once you are here, it's a straight computation. You can pick whichever one looks easier to you. I kind of like the one on the left because there are 2 zeros in it. So I'm going to do the integral from 0 to 1. I'm going to integrate with respect to y. So treat that like it's a constant. That means this is going to be xy minus or plus y cubed from 0 to 3x dx. We're going to plug this in. We're also going to plug the 0 in. You get the integral from 0 to 1 of 3x squared, because you're putting that there, plus, let's see, 3x cubed. That's 27x cubed. And this does represent, still represents the cross-sectional area. And what did I choose? I choose to do it with x fixed. So let me show you that cross-sectional area. In terms of x, let me get rid of these so we can see it more easily. Here, here. So let's look at the cross sections in terms of x. If you increase x, here's what we're getting. Those are the cross sections. The area of one of those orange things is 3x squared plus 27x cubed, this formula here. Okay, so then you say, now I'm going to add up those, and so you get x cubed plus 27 over 4x to the 4th from 0 to 1. And so you get 1 plus 27 over 4, which I think is 31 over 4 cubic feet or whatever. Okay, that's the nature of these questions. Okay, so if you are fuzzy at all about how I got those bounds, please ask on the discussion board. Please peek ahead at the homework. Once you have the bounds, it's computation. All right, let's peek at the homework and see what it looks like. Here's the 15-2 homework. So these ones, you're just straight computing, so I don't think I'll do these. You're just integrating. You might try to see if you could draw the region. Let me get rid of this picture here because it's in our way. Here's another one that just says integrate. Interestingly, I think after you integrate, you're going to get an s cubed cosine of s to the 4th. Hopefully you know how we're going to integrate that. If you don't, watch the video on substitution. Here we have another one with a region. Okay, finally you start to get to things where you're going to have to graph something. Take your time. Don't use a grapher. Pretend it's a test. If you need to review which graphs you need to know, watch my supplemental video on that in the primer for chapter 15. So you should realize that this, so if you haven't seen that before, we have quite a few in 125 where that happens, but it's this parabola on its side. And this is a line with intercept at -6. So in our head, we should already have this picture, and it's very similar to one I did in my part 1 of my lecture video. And you should immediately see whether you'd want to use X or Y. Think about that. All right. That's what these are. So then this one, this shouldn't scare you at all. You should immediately say, okay, bounded by what? Bounded by y equals 0. That's this side. Bounded by x equals 1, that's here. Bounded by the parabola. And like I said, you need to practice this. Don't use a grapher. And besides that, if you need a grapher for this, there's a problem. You want to be able to graph these things. That's a very valuable skill. Now you get to choose whether you want to do it in terms of x or you want to do it in terms of y. Both are perfectly fine, but they're going to test your skills of being able to label it in terms of either x or in terms of y. Both are good. You need to be comfortable doing it both ways, and then you have to compute. A triangular region, so you're going to draw, very similar to what we just did. enclosed by this. Sometimes students tell me they don't know what that is, but you should know that it's a half circle. You say, well, how would I know that? You can square both sides, but I also cover that in my video on curves you should know. So there's our region. You can decide whether you want to do it in terms of X or Y. Both are fine. Okay, I think I will stop there. But try to graph it yourself and practice your computation. Use every moment there to do it carefully, because you go, what if that was an exam question? All right, hope that helps.